And then we're going to spend all of our time in 6.3 today. We'll talk about what's going to happen with that. So radioactive decay was where we went last time. We talked about how this is actually, at least I talked about it, how this is actually sort of a realistic situation about how a radioactive substance will decay over time according to the amount present. And so just as a reminder, that's that key phrase we saw last time. A substance decays at a rate proportional to the amount present. You might look at your notes, you might just remember this, but do you remember how to translate that into a differential equation? What is it?
We'll start off with ds over dt.
ds dt equals?
K times s.
Ks. There you go. So ds dt equals Ks would be the differential equation that goes with. And also I mentioned last time that because those keywords such as find the particular solution, show all your steps, show separation of areas, because those words are not there, you can jump, if you want, you can jump directly to the solution curve. So do you remember that, what the solution curve is? CE to the KT. There we go. There you go. So let's, this is kind of where we stopped last time. Let's jump in right here. I want to let you guys know, this is pretty important for this topic, what the C stands for and what the S stands for. Does anybody know from science class? Physics, chemistry, biology maybe? Say again? Lowercase c, yes. Capital C, in this case, no. It is not the speed of light. Something else.
Isn't it the constant or is the constant proportional something?
That'd be the K. That'd be more the K.
Isn't, oh, I know KE is kinetic energy. That's just
Thank you, Natalie. C is the initial or the beginning amount. We're talking about kinetic energy and the speed of light. Natalie, you cut through all of it with a good answer. Nice job. C is the beginning amount. What does the S then stand for?
The end amount. Substance, the amount of substance.
So end amount is a pretty good way of putting it. Can I call it like the amount at any time? The amount at some time? So if we wanted to say the amount at T for time, the amount at some time. So let's try to make this fit with our situation right here. We got radioactive decay. So in other words, this substance, the amount of it is lessening, right? It's decreasing. So what's the relationship going to be between S and C?
S is going to be less than C.
Shouldn't S always be less than C? In only one case it won't be. That's when T is 0, right? When T is 0, S will equal C.
Or when time goes backwards.
Yeah, if time goes backwards, yeah, maybe. But in any realistic case, for any time other than 0, won't S have to be less than C? Okay. I think that's pretty important when we try to answer this question coming up. Now, it says if 30% of such a substance remains. So that's how much is there, right? There's 30% that still remains. After 16 years, what is the half-life of the substance? We'll talk about half-life in a second. That's a very sciencey word. But let's talk about this whole 30% remaining after 16 years. I really think, and hopefully you'll agree with me, that in order to answer any of these questions, we got to know what the K is, right? Okay, so we're going to use this first sentence, the 30% remaining after 16 years. We're going to use that to help us find the K. And I'm going to propose this. What if I took this equation right here and divided both sides by C? I would get this. S over C equals e to the KT. S stands for the amount of substance that you have. C is what you had to begin with. And then furthermore, what if I took it one step further and I said T is 16? So e to the K times 16. At this point, can you tell me what the left side would be?
Yes.
What?
It would be 30 over 100.
0.3, 30%, 30 over 100. Yes, it would, because what this says is that after 16 years, 30% remains. So if S is the amount that you have still remaining, and C is what you had to begin with, S over C would have to be 30% at this point in time, right? Isn't this how you figure out your grades? Like if I hand you back a paper, a quiz or test or whatever, and it says 16 out of 19, do you look at that and are you just like totally sad? You're like, oh, 16 out of 19, I got a 16%. Oh, no, you don't do that. What do? You go 16 divided by 19. Oh, look at that. That's an 80-something. Okay, that's not so bad, right? It's certainly not 16%, right? And so here, whatever the S is, we have no idea. Whatever the C is, again, we have no idea. But we know that if 30% remains, S over C, that's the 30%. That division is your 30%. So I'm going to put 0.3 equals. Now, how do we find the K? The K is up in the exponent, so how do we get that out? ln, yes. So ln of both sides. Oh, yeah. Very good. All that work in pre-algebra, or not pre-algebra, pre-calc is coming to play here. So ln of 0.3 is equal to 16K. Divide both sides by 16. Now please use your calculator. So we need to do ln of 0.3 divided by 16. And I'm going to give you the advice of we're going to keep all the digits. Not most of them, all of them. And I'll explain why in just a second. So just do that little arithmetic there and let me know what you get. Dylan, do you have it?
Yeah.
Go ahead.
Got negative 0.07524830003.
Sorry, I'm feeling slow today. I got 0.0752.
4830003.
Okay.
All right.
So the fact that that's negative makes a lot of sense. Did you guys get the same number as well? Okay. Getting a couple of yeses and some head nods. I didn't see any thumbs up. Oh, I just saw a thumbs up. Never mind. We're good. So it's really important that we keep all the digits here, that you store them in your calculator, simply for this reason. When we're talking about exponential growth or decay, it has the potential to be very fast one way or the other. And so if you cut it off right here, if you said, hey, I'm going to do like I'm going to do 3 decimals and just cut it off right there, your end answer will likely be way off. Not off by like tenths or millionths or hundredths. It could be off by the ones or the tens place value potentially. And so what you want to do is you want to keep every single digit, store it in your calculator, go store alpha A like we've done before, but keep all those digits so that your later calculations will be accurate. Okay, so I'm going to rewrite it over here. Rewrite the whole thing. It's going to be S equals C E to the negative 0.0752 T. I'm not going to write all the digits on my paper. I'm just going to store them in the calculator, right? You can just write a number like that, knowing what it actually stands for. We okay with finding the K? Does that seem logical? You have any questions? Okay, let's answer the final question then. It says, what is the half-life of the substance? So it might be worth talking about this. What is a half-life? Okay, so the first word you said was? When. So what kind of a thing is half-life?
Time.
It's time, right? So it's a time, and you said, Natalie, time when? Half of it remains, right? So the time necessary for half of it to decay to just having 50% that's there. So it's a pretty standard scientific sort of a calculation. So in the end, we're looking for a T, right? Because she said when. So it's the time when we only have half of the substance. So I see a T right there. So I kind of feel like we're going to end up solving for T in the end. So that means we got to have something for S and maybe C. Yeah, so it needs to have a relationship of 50%. Now, we don't know what C was, but because we're looking for half-life, if I do the same thing I did before, I can say S over C equals E to the negative 0.0752 T. Whether it's 50 and 100 or 30 and 60 or 2 and 4 or 500 and 1,000, we know that S over C will have that relationship of 50%. Half-life, right? I'm looking around seeing really confident faces. Am I reading you right? Okay, cool. All right, so 0.5 equals E to the negative 0.0752 T. Just like before, our variables in the exponent, so what do we use? Natural log. So natural log of this, natural log of that. Now whether you kept all your decimals or not is about to matter. So make sure that you've kept all your decimals for the K value from before. It's going to be ln of 0.5 divided by that negative 0.0752 number equals T. So once you have a number calculated, let's hear it. Let's see how it turned out for you.
9.2 years.
9.211?
Yeah.
Okay. I think we did this in the other class, and I think we came up with that same number.
1.46627.
Where do you go from there though? Just like click it, I don't know how to store, I never.
Oh, I'll show you. Yeah, so what I would do, so that's what goes in the blank. We're going to separate the variables first. I'll just see if I can squeeze that in there. I always get messed up on the word separate. Is it S-E-P-E or S-E-P-A? A, okay. I always get messed up. I used to be a really good
It's
speller.
an I.
Or maybe a U. U would also phonetically work. Separate. Separate. Yeah, I don't think so. Okay. So, again, I just want to say it again
It's a Samoan.
because I just want to just be really clear about this. You know, on an AP test, I want you guys to feel like you know, if you deserved a 5, you got a 5. If you deserved a 4, you got a 4. This would be one of those things that would be frustrating. If you don't show separation of variables, this is probably going to be an FRQ. It almost always has been. If you don't, you get nothing. And that would be a shame because you probably should be earning 4 or 5 points. At one point or another, you've all shown that you can do this. So please, show that separation of variables so that you can be rewarded for your hard work. All right, so let's practice in number 1. Let's just make sure we know how to separate the variables. Would you guys please try that step? Separating the variables. We're trying to find the general solution to this differential equation. Separate the variables first, and then we'll proceed from there.
How are you feeling, Mr. Anderson?
Better. Better than yesterday. Did you guys get y dy equals 3x squared dx? I think another way to put this, and this is sometimes a good way to go, a lot of times it's a good first step, couldn't you have just cross-multiplied here? That's essentially what it is. It's two ratios being equal to each other. You can just cross-multiply, and that sometimes will get you to a good place. Not always, but sometimes. This time it did. Okay, once you separate the variables, what always comes next? Yep, we're going to find some antiderivatives here, so those little integrals go in there. On the left side, what is the antiderivative of y dy? Y squared over 2, agreed. Equals, how about the right side? Just x cubed, right? Yeah, 3x cubed over 3. And then I want to clear up any questions at this point. We customarily put the plus c on the right side. Are you guys all okay with that? Do you understand why there's not a plus c on the left side too? If you're wondering, let's clear it up. It's okay.
Is the plus c just a combination of the left c and the right c?
Yeah,
Yeah.
yeah. Essentially, that's what it is.
Minus a constant.
Could you leave the plus C off to the very end, or do you have to put it on?
Okay, now that's a really good question from a grading perspective. Did you hear Chloe? Chloe said, tell me if I'm wrong here, but I think Chloe said, do you have to put the plus c on here, or could you put it on at the very end, right? The answer is you really have to put it on now. So once you have done the antiderivative stuff, the plus c really needs to be there at that point. That'll make a huge difference when we're actually doing problems where you can find the c. Timing will be everything, really, in addition to the math skills, but timing will be important. Yeah, question?
Would it be wrong if the plus c was on the y side?
Technically not. No, I can't see anyone having a good reason for marking that wrong. It just, I guess I am coming from a grading perspective. I would like to make it easy on whoever's reading your test.
Yeah.
And so the custom is to put it with the independent variable. But yeah, C on the left, that would work out just fine. It really would. Okay, so if we're trying to find a general solution, we have to acknowledge that we're not going to be able to find the C because we don't have enough information to find the C, but we can at least solve for y, right? So what would you guys do first if you were going to solve for y? Yeah, multiply by 2, so y squared is equal to 2x cubed plus 2c. Let's remember that 2c is just some other version of a constant, so it could just be a c there. And the final step would be to square root both sides. Let's also remember, this is pretty crucial, that plus or minus needs to be in there whenever you square root both sides. That's something that will definitely come into play at times, but please don't ignore that. And that would be our general solution. There's really nothing else we can do with it. If we had an initial condition, we could find the C and give a particular solution, but that's all we can do with what we've got. Any questions? Okay, so hopefully number 1 was a good reminder. Question, yeah, go ahead.
Would it be wrong if I left the 2C together?
No. I would say like these general solution style questions, pretty frequently would be a multiple choice. And I don't think you'd find a 2C option on the multiple choice. You certainly wouldn't find one where it's, root 2x cubed plus c and the other one root 2x cubed plus 2c. You would never find those two.
Okay.
So you wouldn't have to make a choice between the
Would
two.
the two matter with like finding the particulars?
Yes, it would very much matter. The timing would come into play there.
Okay.
Yep. We'll talk about that in a few minutes. Yep, good question. Any other questions? I really, really appreciate your questions. That's what drives us to good places. I can sit here and talk. All that really proves is that I know what to do. Doesn't really show anything for you guys. So if you have questions, yeah, go ahead.
Sorry, I think you might have just said this, but do we have to put the plus c in the square root?
It does have to be in the square root, yeah. And the reasoning would be this, like when you square root the left side, you have to square root the entire right side in its entirety. You can't do this.
But isn't the square root of c just c?
Oh, be careful.
That's plus or minus c.
Be careful. I guess,
Let's
I don't have a working phone, but I could call the math FBI here. So let's be careful. I'm being facetious, right? Okay, so let's be really careful with this. Let me make sure I understand. No, these are the kinds of questions you got to ask, because there's no good reason to miss points because of misconceptions, possibly like what we have. So Titus, I want to make sure I understand what you're asking. Are you wondering if we could go essentially to here and say that root c, like you said, is just c, right? So that.
Yeah.
So this is a very bad dark place in the math world.
Got it.
So I'm going to erase this real quick, but can I prove that to you, Titus? I don't want to just call it a bad thing and then just leave you to say, oh, okay, gosh, I guess it's a bad thing. The best way, Titus, the best way I know how to do this for you is just to use some numbers. So check this out. If I just have some square root, I'll use easy numbers for us. I'm going to say 3 squared plus 4 squared. So let's do it the way that we know how, because let's do order of operations, right? So order of ops says do the exponents. 3 squared is 9 plus 4 squared is 16. You get 25, right? So it'd be square root of 25, and that's equal to 5. That's doing order of ops. If we did it your way, we would do this, and we would do this. We'd get 3 plus 4, which is 7. So if they were equivalent methods, we should get the same answer, right?
Yeah.
So that means one of the two is wrong, because we didn't make any like arithmetic errors.
Yeah.
And so, well, no, it's not about whose answer is right or wrong. It's the one that we followed order of operations. That's the one that has to be right. The other one is the questionable one. Maybe it's right, maybe it's wrong. I hope that proves that that's not so good. Okay, yeah. All right. Hey, listen, honestly, this has to be, I appreciate you going there, I really do. This has to be like full confession time, right? Like if there's any misconceptions, it might just have to do with algebra or arithmetic or whatever. But if you're thinking, whoa, couldn't it be this? Please ask. Thank you very much for asking. Anybody else? No math FBI is coming. That's just a joke. Okay, good deal. Well, why don't you guys try number 2? I hope number 1 was a good warm-up for you. Try number 2 all the way through to the end, and we'll check. Okay, so separating the variables, as mentioned many times, is mandatory. So here is what that looks like. You could, I think as I walked around, I think everyone had this. dy over 6y squared equals x cubed minus 3 dx. Is that true? Did everybody have that for separation of variables? Did everybody bring the 6 over with the y squared? Yes. There's nothing wrong with that. It wasn't mandatory that you do it that way, but that's an okay way to do it. Okay. So we all good there? So the good news is if this were like a free response question, you all just earned 1 point for sure, which that's the reason to be happy. Next step is finding your antiderivatives. So the integral symbols go in there. The right side, pretty straightforward. It would be 1/3 x cubed minus 3x plus c. The right side is a little bit less straightforward, right, because it's a fraction. So if you think about ln, you would look at the derivative of the denominator, which is 12y. You look at the top would need to have a y in it, right? So it'd have to be something y dy, and it's not. So we'd be missing the y, so it's not ln. The next option is flip up, and that's the right one. I'm going to kind of do 2 steps in one, if that's okay with you guys. I'm going to get the 1/6 out of there, so it's going to be 1/6 integral of y to the negative 2 dy. Does that make sense? What I saw as I was talking with a couple of folks, had a couple of folks flip the 6y squared up, and they flipped the 6 up with the y squared. Remember, the exponent on the 6 right now is a 1, and so it needs to stay where it is in the denominator. But the y squared can go. That make sense? Okay. And then you just use the power rule, so it'd be 1/6 times y to the negative 1 equals all this stuff over here plus c. There we go. Again, saw a lot of people get there. Definitely encouraging. Question, Titus.
Shouldn't it then be divided by -1 on the left side?
Oh, doggone it. Yep, I just totally forgot about that. Yep, so can I just do this?
Yeah.
There we go. So that's, I saw a lot of that. There we go. Thank you. Any questions so far? Okay. So now our final goal is to get the y by itself. I'm seeing, let's get rid of the 1/6 first. So why don't we multiply everything through by -6? That'll clear out all the fraction, the negative stuff. So if I multiply through by -6, that will give me y to the negative 1 equals negative 2x cubed plus 18x. And then it would be negative 6c technically, but that's just still some other c. So I'll just leave that as plus c.
I got it off before.
Still okay? Okay, so the final step, I would rewrite this as 1 over y equals negative 2x cubed plus 18x plus c. The goal is to solve for y, not solve for 1 over y. So we've got to flip the left side, right? And if you flip the left side, that's okay as long as you flip the right side as well. And so technically the right side is just all over 1. So this would be y equals 1 over negative 2x cubed plus 18x plus c. What do you think? Question? John? Okay. Go ahead, McKenna.
So it was negative 6c.
Yep.
So, will it never be negative c? It'll always be plus c?
So we'll always leave it as plus c. Like we're going to say any constant times c, whether it be a positive or a negative times the c, will just end up being plus c. Because if c was negative to begin with, well now it's a positive. You're going to find that with these general solutions, it's really not going to matter that much. With the particular solutions, the timing on how you deal with the c's and maybe the negative 6c will matter.
Okay.
And I'm going to try to help you with that to be consistent. But for these, it really doesn't. Anyone else with a question, thought, comment? Okay. We're going to continue the theme of not rushing. So let's go ahead and do another example. And we'll take our ask here a little bit. It says, find the particular solution, not the general solution. Find the particular solution. And again, just a reminder that we are supposed to use separation of variables. And then, of course, the other piece of information that's given is this initial condition. So this is quite similar to what you guys have done before. There's some important differences. Can I just let you give it a shot? I think you can do a large part of this probably quite well. So let me just turn it over to you for a few minutes, see what you do with it, and then we'll check and see how you did. A suggestion as far as what I think is best. But this can be done in several different ways. The one thing you can't avoid is you've got to show the separation of variables. So to show separation of variables, it would look something like this. Y dy equals 6x dx. So if you all have that on your paper, then that was point number 1, right? On your quiz, your test, whatever. The AP test, that's a for sure. Take it to the bank. Good job. Okay. Second step is to find the antiderivative of both sides. So we put in the integral symbols there. The left side you end up with 1/2 y squared. The right side you end up with 3x squared plus c. So far so good? Okay, now I'm going to make my recommendation right now. You know, because they asked for a particular solution, they gave you that initial condition, y of 2 equals negative 2. Because of what they asked for and what they gave you, you know that you can find the c here, right? Here's my suggestion to you. Right now, immediately after you find your antiderivatives and put your plus c in there, go ahead and apply the initial condition and get ready to find your c. Do it now. Don't mess around and solve for y and do all this other stuff and then try to find it. Do it right now. I think it's just as easy as any other way, and it potentially gives you more points, right? You can't like talk your way out of points if you just apply it right now. So a lot of times, this right here, completing this step by writing 1/2 times negative 2 squared equals 3 times 2 squared plus c. That's going to complete what probably would be the third point. So y of 2 equals negative 2 means that when x is 2, y is negative 2. I would do this now, not later. Okay? It's my recommendation. In a second, I'll show you how you could do it later and still get the same answer. Okay, so here we go. I'm going to work on some arithmetic here. I think this ends up being 2. This ends up being 12. So what's my c value? Negative 10. Okay, so negative 10 equals c. How does that feel to you guys? Did you guys get the same?
I did not.
Okay, now,
I didn't use.
depending on your timing, this could still work out in all of our favor. Let's see how it turns out. What I'm going to do now is I'm going to take this negative 10 and I'm going to plug it back into the exact same step that I used to find my c, not some other step. So I'm going to take this negative 10 and I'm going to plug it back in all the way right there. So here's how this will finish. I'll start down here again. It'll be 1/2 y squared equals 3x squared minus 10. And now my final goal is to solve for y. So if I'm going to solve for y, I need to multiply to get rid of that 1/2. So I need to multiply through by 2, right? So I'm going to multiply everything through by 2. That'll give me y squared equals 6x squared minus 20. And then my final step is to square root both sides. So y equals plus or minus square root of 6x squared minus 20. I'm not quite done yet, but do we agree now?
Yeah, we do.
To see how timing matters? If you get the timing consistent, then it's going to be okay kind of no matter what you do with the whole initial condition thing. If you mess up the timing, it's going to go badly. The final thing we have to decide is this. Is the answer y equals plus the square root of 6x squared minus 20, or is it y equals negative the square root of x squared minus 20? The reason why we have to make that decision is because the solution curve for a diffie-q has to be a function, and with the plus or minus in there, it's not a function. It won't pass the vertical line test. So we got to pick plus or minus. Anybody have any ideas? What do you think?
It's minus.
Why?
Because y of 2 equals negative 2.
Yep. The y value in your initial condition was negative, and so that tells you to use the negative in the square root. So my final answer would be y equals negative square root of 6x squared minus 20. Final. Okay, can I show you a slightly alternative method? Okay. So I'm going to start right here. I'll use a different color so you can see that it's supposed to be different. I'll go with that. So I'm going to start right here. 1/2 y squared equals 3x squared plus c. I already separated the variables, already did my antiderivatives. So did any of you take this right here and solve for y?
Yes.
Okay, so this can still work. So you multiply everything through by 2, and when you did that, did you get y squared equals 6x squared plus c? Did you say that 2c was c? That's fine. And then did you go to the square root where you have y equals plus or minus square root 6x squared plus c? Okay, this is totally fine. Now you apply your initial condition, right? So you say y is negative 2 and x is 2. And now we're going to try to solve for c. So we're going to be undoing some of the stuff you just did, right? So we're going to square both sides. So we're going to get 4 equals, what would that be, 24 plus c? You subtract 24, you get negative 20. This would be, hey listen, this would be a point where if you're working next to somebody, or maybe you do this problem twice, and you look at this point right here and you see, look, c equals negative 20. Oh my gosh, you got c equals negative 10. One of us must be wrong. Wrong. You're both right. You timed it differently. Didn't you time it differently? Because check this out. Please listen, please listen. If I were to take this negative 20, and if I were to plug it back in over here, that would be bad timing, wouldn't it? Terrible timing. So I'm not going to do that. I'm going to take that negative 20, and I'm going to plug it back in to the step where I first plugged in my initial condition. So that would give me y equals plus or minus square root of 6x squared minus 20. You pick the minus, for the reasons we talked about before. We get the same answer, right? So, my recommendation is the first way I showed you. Simply because the way the points typically work out, applying your initial condition is often going to be kind of that third point. And to delay that third point through these extra steps up to there, you possibly could make mistakes, which would maybe talk you out of that point. And so I would suggest that as soon as you do your antiderivatives and you get your plus c in there, plug the initial condition in immediately, find your c, and then solve for y. I think I just showed you that you can do it the other way and be successful. So if you're determined to do it that way, that's your business. That's fine. Your choice. But I do recommend the other way. So, any questions? You guys are already dabbing over all this? I don't know. So with number 4, please take some care with this. The separating of the variables could be a slightly more challenging proposition. Take your time, separate the variables right. Once you've done that, you should be off and running with antiderivatives and initial conditions and all that. So again, please try this on your own, and we'll check it in a couple of minutes. Okay, so separating the variables with number 4, it's going to involve, like I said, just a little bit more. dy dx equals 5xy squared, just by adding 5xy squared to both sides. Saw most folks with that. Can we stop the dab contest? Thank you. So when you fully separate the variables, you should end up with something like that, right? dy over y squared equals 5x dx?
Absolutely.
Okay? So doing an antiderivative on both sides, the right side ends up being 5/2 x squared plus c. The right side you got to flip up. When you flip up, you end up with negative y to the negative 1 for your antiderivative. And again, so most folks had that, right? Okay. So this is where I would recommend plugging in your initial condition. So when x is negative 2, y is 1. So this would be negative times 1 to the negative 1 equals 5/2 times negative 2 squared plus c. The whole left side just ends up being negative 1. And the right side ends up being 10. So 10 plus c. So I'm getting negative 11 equals c for my c value. Okay? So it's really important that I then take that negative 11 and I plug it in where I applied my initial condition, which is right there. That would give me negative y to the negative 1 equals 5/2 x squared minus 11. My final, yes, sir.
Wouldn't it be better to wait till the end to do the initial condition just so that you don't mess up your constant when you're solving for y afterwards?
No, actually it's not. From a points perspective, it's not. The higher value is placed on applying the initial condition.
But as long as you remember to do that in the end, then there'll be less.
If you mess up the solving, perhaps not, right? So if you mess up the solving to the degree that your general solution is something of a different nature than what it should be, then no. So that's why I say to do it immediately, you get the points. And then the last point is pretty involved, like you got to solve for y and try not to mess up the c value. But all of that is just worth 1 point versus, so you would do a ton of work to get 1 point versus just immediately plug in. Just that immediate plugging in is worth 1 point.
Okay.
So and I'm thinking of it as from a time perspective too. Like if this happened to be the last question you worked on and there's only a minute left, boom, just plug them in, point. Versus I always have to solve for y, and maybe you run out of time and you never plug in your initial condition. That would make a difference too. So you're bound by your limits of arithmetic powers either way. So I'm just trying to help you squeeze as many points out as you can per time.
Yeah.
So fair question though. I would multiply through by a negative, right? Because we're trying to get the y by itself. So that would give me y to the negative 1 equals negative 5/2 x squared plus 11. And then I saw a lot of you guys doing something similar to what we did before, which is this. La, la, la. And then, did you flip both sides? Flip both sides. So you end up with a final answer of y equals 1 over negative 5/2 x squared. Oh boy, that didn't go well. x squared plus 11. Okay.
Could you leave it like that, or would you have to like do something with the 2?
You certainly could. You could get a common denominator and add and do a copy.flop thing, but unless it's a multiple choice and you got to do that, don't do it.
Yeah, it was
Yeah, because you remember like back in like 7th and 8th grade, like your teachers, like there were certain commandments, like thou shalt never have an improper fraction,
yeah.
and thou shalt never have like a fraction within a fraction. Like both of those were like unbreakable, punishable by death commandments. We don't really care. We simply don't care. In fact, haven't we learned that we prefer improper fractions probably as opposed to that mixed number junk? And with this, you could neaten it up and do that, but we don't really have to. It's an equivalent answer. Okay, so I want to spend, hey guys, I think this will be worth our while. On Monday, this will definitely become an important thing. Look at the right half of the page. I'm just going to box something off here, and I want to see if you guys remember or if you've ever seen. I don't know if you've ever seen this, and so if that's the case, this will become very important. On Monday, we'll deal with the absolute value thing. I've kind of been hinting around at it, and like, how do we deal with this absolute value thing? And here is where I'd like to leave our week with the definition of absolute value. And this is the true definition of absolute value. You've all heard it like, I don't know, what is it? The value of a number without regard for its sign, right? The distance from 0 on the number line. These are all good descriptions of absolute value. What I'm about to show you is the definition of absolute value. Maybe you've seen this, maybe you haven't. Here it is. It is a 3-part definition, and this will be important for us to consider on Monday and days afterwards. There are 3 types of numbers in this world, 3 types of real numbers in this world. Positive ones, negative ones, and 0, right? 0 kind of gets its own little category. So the absolute value of x is equal to x if x is positive. Absolute value of x is just equal to whatever x is if x is positive. So an example of that would be absolute value of 10. What is it? 10. Okay, so that's that case. The absolute value of x is equal to 0 if x equals 0. So if x equals 0 and you're doing the absolute value of it, then you just get 0. For most folks, the first 2 parts of this definition make a lot of sense. The last one might make you think a little bit if you haven't seen this before. The absolute value of x is equal to negative x if x is negative. This is a key part of this definition. So if you're doing the absolute value of negative 12, the answer is negative 12. Also known as positive 12, right? 12. But this is a very important part of the definition. This will very much come into play on Monday when we finally, for once, deal with those absolute values that I've talked about before. But that'll all happen then. So in the meantime, have a great weekend.